Hi, I'm John Applegate, and I teach physics and astronomy at St. Andrews, and have been working at St. Andrews since 1987 from using with the astronomy class the Spiral Isle Observatory. And I think the eclipse will really be a blast for everyone, and I really like how St. Andrews is getting everybody out to view it. It won't be totality, but it'll be pretty darn good at roughly 86% eclipsed. And you'll need your glasses to view it, as you probably know. I won't talk about all the scientific aspects of it. I think you can, if you're curious, you can search that stuff out on YouTube or the internet, et cetera, but I will sort of try and convey a little bit of the excitement of it. Modern man, we spend very little time looking up at the night sky. And if we look at it, we just, there's a bunch of white dots up there, and then we move on. And a lot of people are in such light polluted condition that it's even tough to see those stars. Certainly not the Milky Way any longer. Most people can't even see the Milky Way. So, but the point is that when we look up, we don't really observe, and it appears to us to be static. All those dots look about the same from night to night to night. Yeah, we see the moon move in the sky, et cetera, but we might not even look at the moon very much. And so I think, modern man needs this jolt of activity in order to see it, make us curious and so forth. We're so used to things being instantaneous. Well, the solar eclipse is pretty close to that. It still takes a little bit of time, 3 hours, but you can really see change taking place before your eyes. And it's a power beyond mankind. Mankind has absolutely no control over it. And I think that's also part of the excitement, that we're really part of the universe. And when we look out and we look out, we think, well, we're really separate from all that, but we really aren't. And so that really brings home a couple of things. One, that change is occurring up there. It might occur on a really long time basis, like geology or something like that, but it occurs, and this is really neat because you can see it as it happens, and it just takes a few minutes. You see that moon move in front of the sun. And that's the other thing. As you look out at the sky, everything appears to be two-dimensional. That is, you don't see something further away than something else. It might look bigger, et cetera, but as some of those stars up there, you really can't tell those stars are any farther than the planets. And you really can't tell a star is farther from another star. And then when you see this eclipse occur, you think, oh my goodness, here comes that moon. It's sliding in front of the sun. Yes, indeed. I've been told ever since I was a little kid the moon is closer than the sun. And now I can see it. There it is, taking a bite out of the sun. So I think those two things will really be really neat and worth your time to get out and look and see. Thanks very much. I hope you see it.